Let us solve this question. A piece of wire is bent in the shape of a parabola y is equal to kx square with a bead of mass m on it. The bead can slide on the wire without friction. It stays at the lowermost point of the parabola when the wire is at rest. Yes, we have taken a wire which is bent in the shape of a parabola and the bead is present inside the wire which is having a mass m. And when the wire is at rest, the bead will take the lowermost position of the parabola. So it will be at the lowermost point just to have the equilibrium. And they have given the wire is now accelerated parallel to the x-axis with a constant acceleration a. So we have to understand the wire is under acceleration in the positive x-axis. What will happen to the bead which is present inside the wire? The bead will experience a pseudo force because the wire is accelerating in the positive x-axis, and the pseudo force will always act in the opposite direction to the direction of motion of the object. So let us assume due to the pseudo force the bead is coming to this position, and now we have to draw the free body diagram for this position. We know that the normal reaction will always act perpendicular to the surface of the object, and the weight will always act in the downward direction irrespective of the shape of the object and irrespective of the position it was placed. Now what I am going to do is I am going to draw a tangent at this particular point. Now see here, this tangent makes an angle theta with the horizontal. Yes, so now the normal reaction is resolved into two components, and you check, we know the alternative angles are equal. So if this is theta, then the alternate angle here will also be theta. And what about this? This will also be theta. Okay, because here it will be 90 minus theta. If this is 90 minus theta, and you know, between the vertical and horizontal axis, the angle is 90 degree and the remaining is theta. So obviously this component will be n cos theta and this will be n sin theta. And we know the pseudo force has taken the object in the opposite direction to the direction of acceleration of the body. So pseudo force will act in the negative x-axis. That's all. Now we have to equate the horizontal and vertical component. Equating the vertical components, n cos theta is equal to mg. Equating the horizontal components, n sin theta is equal to f. And you know f is the pseudo force. So this is pseudo force which has brought acceleration to the bead. So n sin theta is equal to ma. And now let's take this as first equation and this as second equation. Let's do 2 divided by 1. Tan theta is equal to a by g. And let's take this as equation number 3. From the given, that is the equation of parabola y is equal to kx square, let's differentiate the y with respect to x. So what is the answer? Dy by dx is equal to k into 2x. And why I have done like this? Because this is change in y-axis by change in x-axis, which is always called as a slope. And slope is always taken as tan theta. So what is the tan theta answer now? It is k into 2x. So I have another equation for tan theta, that is k into 2x. Let's call this as equation number 4. So equation 3 and 4 has same LHS. So let's equate the RHS. And now a by g is equal to k into 2x. From this, x is equal to a by k into 2g. That's all. This is the position of the bead from the y-axis.